Duchesses and Dukes of Display. It's Prof G, and it's time to get a little graphic. That is, by adding images to our display. Now we'll learn how to load images that have been saved to our board, and we'll place them on screen. And we'll add text labels in front of the images, and we'll toggle between images by setting the hidden property. Now I'm going to focus on TFT and OLED style displays here. I'm going to continue using the 2.2-inch TFT display that I used in earlier lessons, but these techniques also work with Hub 75 LED matrices, like the 64 by 32 matrices that my students use, but there are a few more quirks in getting images to look great on those devices, so I'm going to cover the Hub 75 LED matrix images in another lesson. Now we're going to be building on knowledge from our prior lessons. Earlier lessons on configuration and setup can be found in our course playlist. Check that out if you need to, but if you're ready to get started, well, let's code! Now if we're going to load images on our display, we first need to get images on our board, and I've got some images for you in a folder named Images that you can find at this GitHub repo URL. You can also find that URL linked in this video's description. Just head there in a browser, click on the green code button in the upper right hand corner, pull down and select download the zip. Find and uncompress that file if you need to. Make sure your board is plugged in and appears on your desktop as CircuitPy. And I've got a fonts folder in here, but if you've been following our lessons in order, then you've already got the fonts folder on your board. If not, you can drag that over. No harm in replacing it, but definitely drag over the images folder. Drop it right in your CircuitPy volume. I'm a scuba diver. I love adventure travel, so these are images from my trip to the Ningaloo Reef in far northern Western Australia. By the way, these are the fonts. We're going to work with the Helve B18 font. Inside images, you see two aquatic images. They're in BMP format. Images need to be in BMP format for the CircuitPython technique we're going to be using. Again, I'll show you how you can convert most images to the format that you need in a future lesson, but if you're working with anything that allows you to save BMP images, save to the 16-bit RGB 565 format, that's what most TFT displays use. The downloaded images and the LED matrix images are for future lessons. You can ignore them for now. Now let's open PyCharm. I'm going to start from scratch. We need a properly configured display. I've got setup information for my display in the CircuitPython school tip sheet. If you've been following our lessons, you're familiar with that, so I'm going to head over to that URL now, find the code for the ILI display, copy it, head back to PyCharm, and paste it over top of anything that might be in code.py. Now let's change the first line of our code. That's always a comment that contains the name that we're eventually going to save this file as when we back it up. How about image-display-py? And let's change the message in the print statement just before while true. Why don't we say image code running? And let's set up a group and our font. So we say group equals display.io.G group, open and close parens. And then we say display.root_group, and that equals group. We've now got a canvas on our display that we can add objects to. And let's load in a font that we can use. Why don't we call this label_font, setting it equal to bitmap_font.load_font. And this method requires a path where it can find fonts, so we'll pass in the string /fonts/HELV B18.bdf. And now let's learn some new things. First, we're going to read one of the images that we saved to our CircuitPy board. People sometimes refer to reading the images this way as reading an image from disk, even though there's not a physical disk on the board. But to do this, we're going to use a class called onDiskBitmap, which is part of display.io. Now this doesn't load the whole image into RAM. Instead, what it does is it creates an object that lets display.io stream pixels directly from the file, which is super efficient on limited memory boards like we use for Maker Electronics. Now we'll put the object that we get back from onDiskBitmap into a tile grid. Tile grids are the object in CircuitPython that know how to draw images to displays. Then we'll append the tile group to our root group, just like we appended labels containing text to our display, and we'll see our images show up. Now we should have all the libraries imported, so we're ready to read in the images from the board. This first bitmap, or this first image that we read in, it's going to be of a whale shark, so we'll just call this WS for whale shark _bitmap, and we'll set this equal to display.io, which is a library, dot, and we want the onDiskBitmap class, and in parentheses we just pass in the string, which points to the path and name of the file we want to load in. That's going to be between quotes, /images is the name of our folder where our images are stored, whale_shark.bmp. That's an underscore, not a dash. Once we've done that, we create this object that can read the image off of our board. Then we attach this to a tile grid. We'll call this ws_tile_grid for whale shark tile grid, and we'll set this equal to, again, display.io.tilegrid, capital T, capital G. And in parentheses, we're going to pass in two things. One is going to be ws_bitmap, that object that we just created above, comma. Then we add this thing called a pixel shader, and we'll set that equal to ws underscore bitmap, the object we read in, dot, and it has a pixel underscore shader property. The pixel shader is just a table that helps our image find out which colors it should use. We're not going to have to use it in any place in our code. Then to see this on our display, we just append it to our group, which is our root group. So we'll say group.append, and in parentheses pass in ws underscore tile underscore grid. Then I'll open the terminal, get into TO, save our work. And look at that. If you're looking at the screen, you're seeing the world's largest fish, the whale shark. They are sharks, but they're filter feeders, not at all dangerous. Now I created this image keeping its original aspect ratio, so it's 320 pixels wide, but only 214 pixels high. It's being drawn from the display's upper left-hand corner, 0, 0. The display's 240 pixels high. That's why we see this black bar along the bottom. There's no image to fill in there, but we can center it vertically by doing this. ws underscore tilegrid underscore grid dot y, and setting this equal to, in between parentheses, display dot height minus ws bitmap dot height. That subtracts the smaller image height from the larger display. Then we /2 because we only want to move down half the difference so that we center the grid vertically. Save it again, and we're looking vertically centered. Nice. And of course, we can add multiple elements to our group. So if we want to overlay the bottom of the screen with the creature's name, whale shark, we can add a label like this. ws underscore label equals capital L label, open and close parens. I'll enter these on separate lines. Font equals label underscore font, comma, text equals, in double quotes, whale shark, comma, background underscore type equals capital T true, comma, anchor underscore point equals, in between parentheses, 0.5, comma, 1, comma, that'll start drawing the label up from the middle bottom. Anchored underscore position equals, in parentheses, display dot width /2, comma, display dot height, comma, that'll move the display halfway over and all the way to the bottom, and our color will be equal to, in between parentheses, 255, comma, 255, comma, 255. Now we'll append this below the tile grid. The last item added goes on top of all the previous items, so we say group.append, in parens, ws underscore label. Open the terminal, we're in TO, save our work, and we see this runs, and now everybody that looks at your display won't wonder what kind of mysterious creature of the deep this is. They'll know it's a whale shark. Now we'll eventually flip between two images, but there are a few other techniques I'd like to show you first. For now, I'd like you to apply what you just learned and accept the Cuttlefish challenge. In this challenge, I want you to modify your existing code so that after loading the whale shark image and displaying its labels, you pause for 5 seconds, then load an image named cuttlefish.bmp that's also in the images folder. When loading, you can create variables that begin with cf underscore, and the way that the whale shark variables begin with ws underscore. That'll let us compare our work. And again, we'll eventually flip between images and we'll add a label here, but there are a few techniques to show you first. So why don't you pause, give this a shot. I know you can do it, and let's resume and compare answers. So the solution's very straightforward. After we've appended both the tile grid and the label, we'll time sleep, pausing for 5 seconds. And I'm not even going to rewrite the code. I'm just going to go up here and grab the 2 lines that we used in order to load our image from disk and add it to a tile grid. With these copied, I'm going to paste them below the time sleep, and I'm going to modify the ws underscore to be cf underscore bitmap. I'll change the name of the file we're loading to cuttlefish.bmp, and I'll change the ws underscores down below to cf underscores. And then all you need to do after that is add a group.append, passing in the cf underscore tile grid that we just created. Open the terminal and let's check out TO as we save. And look at that, we get our shark. 5 seconds later, we get our cuttlefish. Nice! Now let's look at our cuttlefish. I want to add a label below, just like I did with the whale shark, but a white label didn't show up very well, and neither did a label with colors, because the colors of the image in the bottom are sort of mixed. So I want to add a background color and padding. And well, let me show you the problem that I ran into. I'd mentioned it during a previous lesson, but then I'll show you the fix that I'm going to use here. Let's first copy our ws underscore label and paste it just above where we added the cuttlefish group, and we'll modify this. I'm going to call this cf underscore label. The text will be cuttlefish, and underneath that, I'm going to set background underscore type equal to false with a capital F. Remember, that's necessary to allow the padding to grow and so that we can add a background color to our padding. Now below the anchor position, I'm going to add the background underscore color equal to, in parentheses, 0, 0, 0. So that's going to be a black background. Don't forget a comma after every line, but we should add some padding around that. So I'm going to add padding top, bottom, left, and right, all of 5. And the color of the text is going to be white, 255, 255, 255. And I'll add a group.append just below the tile grid, appending in the cf_label. It's important to have the label after the tile grid because items that are added later show up on top. Then I'll open up the terminal and we'll save this, and I'm not sure if you can see what's going on here, but there's actually a huge amount of padding at the top of this label. And it's also not anchored properly. You can see the very top of the white letters poking up from the bottom underneath the padding. That shouldn't be happening. The bottom of this label's bounding box should be anchored to the bottom of the display. Now, if your display looks as expected and it doesn't look like mine, then that's a great thing. It means the bug that I'm showing you here was fixed. But if you're having the same issue that I'm showing you here, then I think what's happening is what I mentioned in an earlier lesson. I think there's an error in the bitmap_label library's label class. Normally we want to use this class because it's more efficient and it's newer, but for some reason when we set background_tight equal to false, at the time that I'm creating this lesson, we get a messed up padding on the top and it screws up our proper anchor placement. So what we're going to do in this particular case is we're going to revert to the old label class from the label library. So if your label looks good, don't worry about this, but if your label looks like mine, it's sort of messed up, then do what I'm doing here. We're going to head to the top and we're going to add another import statement. Import adafruit_display_text.label as label. This is going to load that older label library, but it does work when it comes to adding padding and adding a background color. Then we'll change our label code like this. Instead of CF label equals capital L label, we're going to say CF label equals lowercase label dot capital L label. That goes in the label class that we just imported, and it uses that label object. Then we can save this and rerun it. And I've been speeding the video through the whale shark, but hey, it looks good. And you might decide you want to experiment with less padding, maybe not so much padding on the top, but at least we know how to control the problem we had previously. So now we got a label showing up. Let's get these two images to toggle back and forth where each image with its label is shown for 5 seconds at a time. Well, at this time we've got 4 elements added to our group: the whale shark tile grid and the label, and the cuttlefish tile grid and label. Now all 4 are added to the group, but because the cuttlefish takes up the whole screen, you don't see anything behind it. Now here's what we're going to do to show one item and then the other. Now the objects that have been appended to our group each have a parameter named hidden, and it's a Boolean value, true or false. And when it's true, that means that object is hidden. So we can use that hidden property to toggle which item is showing and which one is hidden. Let's update the code that's in our while true like this. By the time we get here, we've just shown our cuttlefish. And actually, let's add a time sleep up top before we get here, just so we show the cuttlefish on screen for 5 seconds. Then we'll set cf_tile_grid.hidden equals true with a capital T, and cf_label.hidden equals true. Then time sleep for 5 seconds, and what we've just done is we've hidden the cuttlefish and its label. That should let the whale shark and its label show through. Then below this, we can say cf_tile_grid.hidden equals false, and cf_label.hidden equals false as well. Do another time sleep 5. And what that's just done is it's made visible the cuttlefish tile grid and the cuttlefish label. And before I make the final run, I'm going to change my padding from 20s to 5s. I think that looks a little bit better. And I'm also going to change my anchored position here. Remember, these values are 0 indexed, so the actual lowest point is not display.height, it's display.height minus 1. So I'll make the change in the CF label and in the WS label. And I think we're good. Let's open up the terminal and save. And let's see, so 5 seconds each for our whale shark, and then our cuttlefish, and we'll toggle between the whale shark and the cuttlefish, looking good. Now be sure to save this to your CircuitPython school folder and close that outermost tab. And once again, we've had big learning. So now you know how to load BMP images from your board. We center them exactly where we wanted them to be. We talked about overcoming what looks like an error in the bitmap labels label class. And we use the hidden properties to change whether or not items were visible on our display. Hope you're feeling like display dynamos, Pythonista. There's lots more goodness to come. Stay tuned, but in the meantime, continue to hack.